We'll talk about it in more detail later on. But just to have a small idea about it, if I had given you an assignment and the question I gave you is to come up with 5 numbers, and those 5 numbers should add up to a total of 20. And I'll say, oh, you are free to choose any number from 0, but if we sum those numbers, the total should be 20. In that, you will have freedom to choose any 4 numbers. But by the time you'll be choosing the 5th number, you'll be constrained, because the constraint is that you want to make sure that the total should be 20. So the 5th number is not any number you can choose freely. You will freely choose the 4 numbers, but the 5th number you say, what should this be? Let's say, for example, you choose 4, 4, 4. 4 numbers, 4. The 5th number, you have no choice. You are forced to choose another 4, 8. Because if you choose 5, it will be 21. If you choose 3, it will be 19. So the fifth number, you have a constraint, which means that you have 5 minus 1 degrees of freedom. You are free to choose 4 numbers, and the 5th number, you are constrained by the constraint I gave you of a maximum of 20. Okay? Is that making sense? Now, in this formula, we have that constraint as we are using the deviation scores and summing them. The last number is a constrained number. You remember the deviation score is coming from x minus mean, the score minus the mean. You remember that? That's how we came up with the deviation score. So the fact that we are removing them from the mean, the summation here has the constraint just like I was demonstrating in those numbers. So in statistics, you will be coming across this phenomena very often. In some statistical formulas, you'll be required to remove 2 degrees of freedom, 1 degree of freedom, depending on the constraints you have in that. I will discuss it in more detail later on, and especially for those doing introduction to statistics. But just for us to appreciate today, I thought we should talk about that. So that's why at the bottom there it is n minus 1, okay? You remember the assignment we had last time, to be able to compute the range, we had to rearrange the numbers from lowest to the highest. Do you have that rearrangement? Okay. Can I have those numbers arranged in that order so that we also have a small exercise on this, so that the formula I'm giving here makes sense. The lowest was 52, 53, 56, 56, 56, 4 56s. 57. Two, 64, 65, 80, and 88. Okay. Let's try to compute a standard deviation using those numbers. We'll do it together. After doing it together, then you will compute a standard deviation on your own for those numbers. Just to be sure we are together. So to compute the standard deviation, we are starting with variance set. The standard deviation will just be the square root, but let's compute the variance. How do we start that? With that formula. First of all, let's take 62 up to 88. Compute the mean of these 5 numbers. Similarly, calculator on your phones. What is the mean of those? (62 plus 64 plus 65 plus 80 plus 88. 359. Okay, divide by 5, The 5 numbers. $71.8. Okay. Now, with that, we need to compute the deviation scores of these numbers. So, the first deviation score is equal to 62 minus 71.8, which is equal to minus 9.8. Okay. The other one is 64, 64 minus 71.8. Minus 7.8. 65 minus 71.7. Minus 6, Minus 6.8. 6.8. 80 minus 71.7. 8.2. Huh? 71.8. Oh, yeah. 71.8. Yes. But I think mathematically, ukwanzanga wa makosa inendi njameni mala kuisa uremba. This one is 8.2. I think I confused you with my 0.7 years. 88 88 minus 71.8. 16.2. Can we add this? Get the sum here. What is the sum? My answer is 0. Zero. Okay. 0. This is you remember when I was explaining why we square this, eh? It's because of that problem. Every time you add the deviation scores, the answer will always be 0 because you have these negatives and the positives canceling each other. So when you are computing variance, when you are computing standard deviation, you have to square them. So let's do that. Minus 9.8 times minus 9.8 equals 19.6 minus 7.8 times minus 7.8. Times minus 7.8. Equals, you need to do it right. Oh, this one is 94.08. Yeah, that's what I thought it should be. $94.08. So you're saying this, you got you shouldn't get negative. Negative times negative equals positive. 60.4. 60.84 minus 0.6 minus 6.8 times minus 6.8. 46.24 minus 8.2 times 8.2. 64. Yeah, 8.2 times 67, eh? Okay. 0.24. 16.2 times 16.2. 62.44. Okay, now let's get a sum of that. Point 0.04. $530.8. Okay. 80. Yeah? Oh, 530.8. Ah, that's okay. When you have two decimal, see, we have been using two decimal places. Then we add a zero there. Okay. So we have solved this upper side of the term, right? In the formula. What we need is to divide this by what? By 4. Why 4? Why not 5? The 5 numbers. We talked about it, right? The degree of freedom. Yeah. MH 290. Nobody? Eh? Muribe. Muribe magere mutoza masasa pawa. Equals what? 132.7. So this is variance 8. That's the variance. That's A. Okay. Explain. It's because of this n minus 1. So our n is 5, 8. Minus 1 equals 4. And we are subtracting 1 because we have 1 degree of freedom to be removed. The constraint I was talking about, eh? Yeah. So that's the variance. To come up with the standard deviation, you should square root that. If you have a scientific calculator, you can do it. The square root of 132.7 is equal to the standard deviation. 11.52. Okay. How we come up with that? Imagine we had 100 scores. Actually, even if I had said let's compute the variance for all these scores, how long it would have taken us? So the process is long. Because of that, there is a formula to simplify this, whereby you use the actual raw scores instead of the deviation scores. Can I remove this? Simwakope. And that formula for the standard deviation but this is also equivalent to this square root of sum of x so you can also compute standard deviation using that formula. Actually, when you enter those scores in a computer, say SPSS or any statistical package, and you request it to give you a standard deviation, it will compute with you that formula. And in this formula, what we are saying here is that you square each of those raw scores, right? When we were doing this one, it would have been 62 times 62 plus 64 plus 64 plus 65 times 65 plus 80 times 80 plus 88 plus times 88. That's the x squared, and then you sum those. Whilst here, what we are saying is 62 plus 64 plus 65 plus 80 plus 88, and the total of that squared divide by n. Then this should be subtracted from that, and that should be divided by n. Okay? So you find very often people are talking about standard deviation using that formula, simply trying to simplify the actions of 62 minus 71, 64 minus, it's a long process. But in terms of definition, that's the formula we use. This one, you start by squaring the raw numbers. 62 times 62, when you get the answer, then you go to 64 times 64. When you get the answer, 65 by 65. And after those squares, then you add them, the summation here. Minus Here, you add 62, 64, 65, 80, 88, and you square that summation, divide by 5. Okay? So when you get this term, you subtract that from what you got here, and then divide everything by n. That will be standard deviation. Any questions? We did that together. Can we compute the standard deviation for 52, 53, 56, 56, 56? As a way of getting used. Yes. Mercedes. Okay. Uh, can one of you go and demonstrate on the board? Okay, no problem. So, I'm going to try, I first type this one. And I write the two that's full. Which was so I'm going to try the two that's also full. Plus
921. And then this was this part. Yeah. For this part, I add up all these numbers. 52, which will be plus 53 plus 56 plus 56 plus 56, which was 273.
Yeah.
Yeah, 273. 273. So I square the 273.
Actually, you have copied this, the formula wrong.
This one?
Yeah. Yeah.
It's wrong.
You not use the square root here.
Yeah.
No. No, no. This square root, this square, yeah.
This is not sure.
Oh, is that what you were saying? But that 273 times 273 divided by 5. You guys want to get that one? Yeah,
I command, okay. In my, when I was solving, I wasn't keeping these 0 points. I was just going to let it, okay, let me just write it first.
Yeah.
4, this is what I
Okay. This is the 74.
This is 15 divided by 5. It's 3, then the square root of 3 is 1.7.
Okay. How this one?
This one? This 14, 49, 5, didn't know the solution. Then I can try to subtract this from this, then I come up with
That's where we can put the because this 273, if you don't just square this 273 times 273, and then the answer which is coming to 4,529 divided by, oh, put that, yes, divided by 5. That's where you can do this. Oh, then you will see. Okay. Ella, did you use the same formula or you use the other formula? What did you get? What did you get? 1.95. Maybe because she rounded numbers to the that's why you are getting the difference of 1.7, 1.95. But you don't come exactly the same number. So we had on the standard deviation S. We know what is happening to come up with the standard deviation. We know what is happening to come up with the variance. So this is the the measure of variability which is used most often, but the only caution is you only use it when you have data which is in ratio scale or interval scale. You don't use it for ordinal scale, you don't use it for nominal scale. I think after that, maybe we can have some 10 minutes and I do some more exercises. Are these exercises helping us? Yes. Okay. Of course, I will not bring these populations in an exam. What I'm interested in is for you to understand the concept. When you go on the computer, you enter those numbers on the computer, it will give you the standard deviation straight without problems. Even various will give you straight without problems. I can give you an assignment, knowing you have more time to work on that so that you get used to that, but not in an exam. But I can ask questions about the standard deviation, about the variance. What does the standard deviation mean? How is it used? How useful is it in statistics? Those things are you should know. But we can go for some 10 minutes. Bonus for computing that. She ran this one. You should have found almost. Using which formula do you use? This one or image? Okay. Yeah, but they should be, you should come up with the same number. Come up with the same number. My suspicion, they are what 27? They are also finding one by seven using this formula. They are not supposed to give you any different results. I don't know why they are getting that difference. Yeah. Yeah? I was supposed to be one teacher. The one who made me now. Oh. Yes. Where I was sick. I was trying to read on my computer that my calculator did it. But it's okay. Another one was app. What is it? It was here? App. And I even got a little so much stage that you want. Instead of finding first the square and dividing by 5, she another way over that 5 with yeah, I thought it should be the same. It's supposed to be what it should come to the same number. with your calculators. So the square root is not there. But I think we have got the idea. The next issue I want to talk about, so in summary, we have talked about organizing data in terms of statistics, organizing data, when we're changing the numbers from the way I had presented them to present them from the lowest to the highest is part and parcel of organization. Then we looked at the graphical presentations of those numbers. It's part and parcel of organization. And then we talked about the measures of central tendency, mode, media, as one of the ways of summarizing.